Hey guys, welcome. In the previous episode, we have seen that to find the best combination of weight and bias, we have taken bunch of lines created from random values of weight and bias. Then we calculated how far the original data points are from these lines, and we represent that calculation in something called loss. And then we selected the combination of weight and bias, which gives us minimum loss. Let's understand this loss function of neural network. Remember, this was our data set. Now let's take a line. So this line was created by using w equal to 1 and b equal to 7. Now you can see we can calculate the difference between original data points and the line we have here by this. So if you take this data point, you can see when x is 5, this is the prediction from our line, and this is the original data set. So the original data set would be 14.5 and the prediction from our line or from our equation is 12. Hence the difference is 2.5. That means this is the gap between the original value and the predicted value. Hence we can call this error, or we can call this a loss. Similarly, when we have x is equal to 25, you can see our model is predicting 32, the original value is 30.6, hence there is a gap of 1.4. This is negative because our model is giving higher value and the original value is lower. Now if we sum all the errors, we'll get a sum of 8.3. So you can see from this line we'll get a total error of 8.3. And if we do the same thing for this line, we'll get the total sum of error is negative 12.7. This is negative because you can see we have a lot of negative values in our difference, and you can see here. Now if we compare both lines side by side, you can see for this line we have a sum of 8.3, that means we have a sum of error, that is 8.3, and for this line we have a sum of negative 12.7. If we look at these two figures, we can see negative 12.7 is lesser than 8.3, hence this distribution is the best fit line. But looking at these figures, you can clearly see this line is not the best fit line. Between these two lines, this line is the best fit line, and this is because we have a bunch of negative values in the difference. Now let's get rid of these negative values in our difference or in our error by squaring these values. So if we square these values, you can see we don't have any negative values in the difference square. You can see here. Now if we check the summation here, if we compare the summation here, this represents the actual best fit line. That means this represents that this line is the best fit line. If we take the average value, or if we take the mean value of this difference square, you can see we have these values, and by comparing these two values, we can say that this line is the best fit line, and this is called the mean squared error. So mean squared error can be defined as the average of squared of all the errors. Now here y, the units of y is in lakhs, hence the units of RMSE will be in lakh square. Now you can see that there is a little bit of odd situation here, that currently we are talking about lakhs when we are talking about y, then when we are talking about the loss function we are talking about lakh square, a different unit. If we take the square root of this RMSE, we have something called root mean squared error, and here we have solved this squared issue with the units. That means units of RMSE will be in lakhs, which is similar to the units of y. Now we'll say instead of taking squares, we can take absolute values to get rid of negative signs, and you are correct, we can take absolute values to get rid of negative signs. You can see here. Now if we take the average, This will also represent the same thing, that is, this line is the best fit line, and this is called mean absolute error. So mean absolute error can be defined by this function, and here the unit of y is in lakhs and the unit of MAE will also be in lakhs. And these mean squared error, root mean squared error and mean absolute error are commonly being used in case of regression problem, and here in our project we are working with a regression problem. Now if you go to this website, you can find other losses, for example binary cross entropy loss or log loss, categorical cross entropy loss, hinge loss, log loss. In all these losses they are being used in case of classification problem. We'll be learning all these losses as we proceed further. You can go to this website also. This has a good explanation graphically about the loss functions of MSE, MAE, Hoover loss and all those things. I'll give links to these websites in the description. Guys, we'll be learning about all these losses. Don't worry about that. For now, I hope you understood the concepts of loss function, how to calculate MSE, MAE and RMSE. So for now, we'll be working with MSE only. In the next episode, we'll be talking about forward propagation, backward propagation and gradient descent. So like, share and subscribe. I'll see you in the next episode. Till then, take care.